Hello students, in this video I will be presenting an introduction of matrix algebra. So I will be starting speaking about matrices. A matrix is a rectangular array of mathematical expressions called the entries of the matrix. For example, a matrix could be like this, an arrangement of numbers. So whatever mathematical expressions, in this case numbers, because this is a rectangular arrangement, this arrangement will be in rows and columns. So this will be a matrix. Or for example, could be something like this. A rectangular arrangement, so in rows and columns of mathematical expressions. You see here that in this case we have numbers and also we have some kind of polynomial here in these entries. Or this entries is the square root of 5x cubed minus 4. Or here there is a fraction in this entry. Anyway, what we have here is a rectangular arrangement of mathematical expressions. Or could be something like this. We have only one row. Or for example, this, it will be a rectangular arrangement with only one expression that will be a negative number. So, if a matrix have m rows, horizontal, so the rows will be the horizontal arrangement, and n columns, vertical, so the arrangement vertical will be the columns. If the matrix have m rows and n columns, we say that this is an m by n matrix. And we say that this m by n is the size of the matrix. So for example, this matrix that has 1, 2, 3, 4 rows and 2 columns, this will be a 4 by 2 matrix. Or this matrix that have 3 rows and 3 columns, this will be a 3 by 3 matrix. Or this one that have only 1 row and 1, 2, 3 columns will be a 1 by 3 matrix. And finally, this one that have only 1 expression will be a 1 by 1 matrix. So what I'm saying at this moment is that a number can be seen as a matrix. So this is a matrix. In modern life, matrices can be found in a variety of settings. For example, can be used to record data in Excel spreadsheets or other statistical softwares. If you see something like this in an Excel spreadsheet, we see a matrix. This is a rectangular arrangement of numbers. And in this case, we have recorded information of the production cost per unit of one company. This company produces 3 types of products. And we see that, for example, for 1 unit of product A, the expenses related to raw material, it will be $0.15. And we see that the cost of labor for producing 1 unit of product B is $0.60. So we have anyway recorded a series of data of the company in a rectangular arrangement. So we have here a matrix. Another matrix that this company can use is this one. This one represents the amount of units produced of each of the products in each of the seasons. For example, if we see this matrix, we know that this company produced 6,000 units of product A in summer. And in fall, the company produced 3,800 units of product B, etc. So this is another use of matrix that this company can use. We are going to use this type of matrix in this course. Another example of matrix that we often see in real life are digital images. And we know that a digital image is a matrix of very small elements called pixels. For example, if we see this image, actually I have zoomed in a picture of one Apple AirPod in one of my ears. You can see the small squares. If we continue zooming, you can recognize here these small squares here. And these small squares are the pixels. Each pixel is actually a matrix. So the digital image is a matrix of pixels. And each pixel is actually a matrix also, because it's a representation of numerical matrix values corresponding to brightness and different intensity of red, green, and blue. So for example, this pixel here, this one here is just a representation of a matrix like this. Information about the intensity of red, the intensity of green, the intensity of blue, and the brightness of this part of the picture. So actually a digital image is a matrix of matrices. The convention is a little different when we speak about digital image. So in a digital image, when I say that the resolution is 1280 by 768, what I'm saying here is that there are 1280 columns and 768 rows. Here, when we speak about matrix in mathematics, we are going to speak in this way: 768 by 1280. So we say first the number of rows and then the number of columns. But anyway, the convention is different, but this is another example of matrix. Matrices also can be used to model some real-life situations. For example, the economics Wassily Leontief used them to model the interdependency of different economic sectors. If we see this matrix here, for example, and we think in a small town that have only 3 economic sectors: farming, manufacturing, and clothing. So we use columns to represent these sectors and also the rows. And if we see here, for example, 0.50, it means that farming is giving 0.50 or 50% of its productions to themselves, to farming. But they are giving 0.30 or 30% of its productions to manufacturing. Or for example, we see here that manufacturing gives 0.30% of their productions to clothing. Again, here we are speaking first about columns and length about rows, different than in mathematics, that we speak first about rows and then about columns. So this number here, 0.40, indicates that clothing gives 40% of its production to farmers. Or this number here indicates that clothing gives 30% of its production to manufacturing. So first, the columns, clothing, is giving 30% to this row, manufacturing. The value in the column corresponding to the sector J, so I'm gonna say the sector J, in this case clothing, and the row corresponding to the sector I, for example in this case manufacturing, represent the proportion of the goods produced by the sector J that is assigned to the sector I. Not all the time, but usually we use J for representing columns and I for representing the rows. We're going to be using matrices in many other situations, in this type of situations and many others. And obviously, we are going to be manipulating these matrices in many ways. We are going to make operation between matrices and also between the elements of the matrices. Instead of being manipulating element by element, we are going to be thinking always in a matrix as a whole. For that reason, we will need some software. And there is a wide variety of software that are useful to matrix manipulation. Some examples are Excel, so this is one that everybody has, MATLAB, Mathematica, this is another software, and R, and many others. However, in this course we are going to be using Excel and R, the two that everybody has at this moment. This R is an open source and can be downloaded for free from this page. If you open this page, you will need to click on CRAN. You are going to find a link for this. After you click on this link, you will be able to choose a location from where you can download it. For example, you can download it from the University of Toronto. Or there will be other locations. There will be locations in many countries. And then choose your operating system. It will be R for Windows, for Mac computers, or for Linux. In mathematics, we usually represent matrix with capital letters and write the element of the matrix enclosed in square brackets. For example, instead of writing this matrix like this, we can say that this is the matrix A, and for making clear that you are considering this as a whole, as a matrix, you can and close them in square brackets. For example, for this one, you can type it in this way. Or for this one, you can type it in this way. For the last one, will be something like this. That's the way that we're going to represent matrix. We are going to use these square brackets, but there will be some textbooks that use round brackets for the matrices. So this A will be a 4 by 2 matrix. This one, matrix B, will be a 3 by 3 matrix. Matrix C will be a 1 by 3 matrix. And the matrix D will be a 1 by 1 matrix. We know that a number is a matrix, but if we want to specify that it plays just a role of a number and not a matrix, we call it a scalar and remove the bracket of its representations. So any way that we want to consider this number just as a number, just remove the bracket. We use the symbol Aij, the same letter that we use for denote the matrix, but a small ij, to denote the element located in the ith row and jth column of matrix A. So in matrix B, then I use a small b for the representation. For example, if I want to represent the element located in the row 4 and column 1 of matrix A, I will be typing A for 1. But if I want to represent the number in the third row and first column of matrix B, I will be using a small b 3, 1. For example, A32 will be the element that is in the row number 3 and column 2 of matrix A. So A32 will be negative 1. A41 will be the element of matrix A that is in the row 4 and column 1. So it will be this 12. A22 will be the element in matrix A that is in the second row, second column. So there will be this 0 here. Or A11 will be the element that is in the first row, first column, will be this negative 3. So in this way we represent the numbers, or we denote the entries of the matrix. For example, if somebody asks me, what is B32? Oh, small b32 will be the element in matrix B that is in the third row, second column. So there will be this 21 here. Or the element b31, so will be the element in matrix B in the third row, first column. So it will be this 15. Or B11, B11 will be the element in matrix B in the first row, first column. So it will be this negative 1. And what about B21? It will be the elements in matrix B that is in the second row and first column. So it will be this square root of 5x cubed minus 4. And what is C11? C11 is negative 21. And C12, it will be this negative 12. And what about this D11? Okay, this will be negative 3. There is no other element in D that D11. So if we want to make a symbolic representation of a matrix of size n by n, the representation will be like this. Within brackets we can write all the elements of the matrix, and of course the first elements in the first column, first row, will be A sub 1, 1, and the last element in this column will be A sub m1, and this m will be the number of rows of the matrix. Obviously, if m equals 4, this number here will be 4, A41. If m equals 7, this will be A71. So the second element in this last row will be A sub m2, and again, m depending what will be the number of rows. The other side, the elements in the last column will be A sub 1n, and this n is the number of columns. If the number of columns is 12, so this will be A sub 1, 12. The second element of this column will be A sub 2n. And the last element of the matrix, the last elements in the last row, last column, will be A sub mn. And again, m is the number of rows and n will be the number of columns. Okay, so that will be the way that we represent a matrix. And let's finish this video by explaining how to enter a matrix in R. Let's see. Obviously, first we need to open R. When we open R, we are going to find a Windows. It will open a window that it will be the command windows in R. And in this command windows, you are going to type the commands that you need to use for entering any functions. So the function for entering a matrix will be matrix. Let's explain this with an example. Assume that we are going to enter the matrix A equal this one here, 7, 2, 0, minus 1, 3, 4. And that's the way that we want to enter the elements in the matrix in R. So we are going to entering from top to bottom and from left to right. So the entering of the element will be 7, 2, 0, minus 1, 3, 4. So you will need to enter the elements and you will need to enter the sides of the matrix. This matrix is 3 by 2. Here beside this symbol that is like greater than in mathematics, type the function that will be matrix. So we type matrix, and this C means combine all the elements of the matrix 7, 2, 0 in the order that I told you, 7, 2, 0, minus 1, 3, 4, and then the side of the matrix. So we'll have three arguments, the function matrix. The first is this C with the elements of the matrix. Within bracket, anytime we type a function in R, the argument will need to be in this round bracket. Then the first argument will be another function, this C, that means combine all the elements. Type in the elements again from top to bottom, from left to right, 7, 2, 0, minus 1, 3, 4. And the other arguments will be the number of rows and the number of columns at the end. If you press enter, it will appear another symbol like the previous one, indicating that R is ready to type another command. As soon as you do that, this matrix, the matrix that we have here, is in the memory of your computer. It's a good idea to type a name for the matrix because you can use it later in other operations. So if you want to see the matrix, the only that you need to do is just press the name of the matrix, for example 8, and press enter. If you do that, the matrix will appear 7, 2, 0, minus 1, 3, 4. So if you need to make any operation with this matrix, you can do it later. Things to remember, let's put it here. Matrix is the function for entering a matrix. This is the first thing that you need to do. You need to type at the beginning matrix. Second, the entries must be entered by columns, starting with column 1. So 7, 2, from top to bottom, first column, 7, 2, 0, minus 1, 3, 4. Third, this C means combine. The first argument, C720 minus 134, tells R what vectors to combine. And look at that, there are several ways to combine this. If you just press this, R doesn't know what to do because R doesn't know if maybe this is a matrix of 1 row, 6 columns. Maybe this is a vector. Or maybe this is a vector of 3 rows, 2 columns, or 2 rows, 3 columns. So entering only this argument, R cannot decide what is the matrix. You will need to tell R how many rows and how many columns. So you must indicate the size of the matrix. The second argument, this one, is the number of rows, and the third argument is the number of columns. For example, if you want to enter another matrix, let's put another example of another matrix with the same elements, with a different matrix. For example, this matrix, B equals 7, 2, 0, minus 1, 3, 4. You see that they are the same element that we had before, 7, 2, 0, minus 1, 3, 4, in the same order. But if I want to enter this matrix, I will need to use the same combine function, but I will need to tell R that this will be a matrix with 2 rows and 3 columns. Let's type it. So it will be B equal 7 2, so B equal matrix 7 2 0 minus 1 3 4, and don't forget to type the size of the matrix. If you press enter, immediately this matrix will be in the memory. You can make operations with this matrix, but if you want to see the matrix, that is the only thing that we are doing today. It will be just pressing B and enter. So, and you're gonna see the matrix that you have just entered. This number here is indicating you the number of the rows. This will be the first row, the second row, and at the top appears always the number of the columns. This will be first column, second column, and third column. So this is what I wanted to explain in this first video, and I hope you have found it useful. Thank you.